A flush in a card game of poker occurs if a player gets 5 cards that are all the same suit: clubs, diamonds, hearts, or spades. Part A says compute the probability of getting 5 clubs. Part B says compute the probability of getting 5 diamonds, or 5 hearts, or 5 spades, or 5 clubs. For part A, I use the general multiplication rule, which is the probability of NF equals the probability of E times the probability of F given E. Part A, compute the probability of getting 5 clubs. So the probability of getting 5 clubs equals the first card is clubs, and the second is clubs, and the third is clubs, and the fourth is clubs, and the fifth is clubs. So the probability of getting 5 clubs equals, we have 13 cards in each suit out of 52. Then once we take it out, we only have a 12 out of 51 chance of getting that the second time, and it keeps going down by 1, down by 1, down by 1, and you get 0.00495. And the reason it keeps going down by 1 is because you don't replace the card back in the deck. For part B, I use the addition rule for disjoint events, which is the probability of E or F equals the probability of E plus the probability of F, and it can extend to as many events as you want. But in this case, we can want to compute the probability of 5 clubs or 5 diamonds or 5 hearts or 5 spades, which is 4 different events that have nothing in common. So we already knew that the probability of getting 5 clubs was 0.000495. So we just times that 4 times for each suit, and we get 0.002.